Hello and welcome to today's Rystad Energy webinar. My name is Isaac Robertson and I'm part of the sales and marketing team. And today I have with me Lars Mikkel Rystad, an analyst here at Rystad Energy. Our webinars run as part of our free industry insights around E&P, oilfield services, shale and the Norwegian continental shelf. We offer various industry newsletters as well as information sessions, webinars and similar types of events, which we invite you to sign up to if you haven't already done so. So keep an eye out in your inbox or visit our webpage for upcoming events and for newsletter signups. Today, Lars will be giving an overview of our OFS solutions. We will now commence with the presentation. On your webinar window, you will find a chat box where you're welcome to raise any questions you may have during or after the course of the webinar. The presentation will last approximately 25 minutes, and with that, I will now hand you over to Lars.
Yeah, thank you, Isaac. My name is Lars. I'm an oilfield service analyst at Rystad Energy, and today I plan to present to you the latest and greatest on our product side for the oilfield service solution. So I have the honor to introduce the WellCube, which will be the newest commercial database in the Rystad Energy universe from January. That part will take approximately 50 minutes, and then I will explain to you how you can utilize DCube for cost benchmarking purposes. And lastly, I will explain to you how we forecast oilfield service providers' revenues in our S-Cube. So with that, I will move over to presenting WellCube. So firstly, here is an overview of the product offering in Rystad Energy. And you can find WellCube on the bottom of the blue boxes under Global Oilfield Service Solutions. Here it's located with, among other, the Demand Cube or the D Cube, where we track oilfield service investments, the S Cube, where we track the revenues of the oilfield service industry, and then also Rig Cube, where we look at the offshore module market in terms of rigs and well counts. WellCube is, like all other Rystad Energy databases, a bottom-up field-by-field database with global content, and will contain information regarding wells in the global upstream industry. The WellCube comes in a familiar Rystad format, namely the Cube browser. It will contain wells drilled and completed for all oil and gas fields, discoveries, exploration licenses globally. Other items in addition to well count is rig demand, drilling length, drilling time series, and active wells. The data is historic from year 2000 and forward-looking up until 2025. Among other, the data can be split on geographies, field size, wellbore purposes, operator, etc. And the demand can, of course, be sensitized on the different oil price scenarios, similar to what we have in other Rystad Energy databases. Here we are looking at the case example with onshore development wells split by country. And this graph highlights the default value item in WellCube, which is the wells drilled and completed yearly. This number is consistent with the UCube production numbers. For development purposes, the wells includes producers, injectors, and other wells. For exploration purposes, it includes wildcats and appraisal wells. As you also see from the chart, we have historic numbers up until today and also a forecast. The historic numbers, well numbers, are calibrated against open sources. In general, this means that the wells are calibrated on a country level, but whenever we have available sources down to areas or basins, we do calibrations based on this. We also calibrate the data or the well count on conventionals and unconventionals. The forecast is made up for all the different oil price scenarios in UCube. And once we have established the well time series, we can start to estimate other items as well, related quantities. In upper left corner, we have active wells, which is the number of wells in operation. This number is determined by the sum of completed wells that has not yet exceeded their well lifetime. On down left or upper right corner, we have the drilling length. We arrive to the total drilling length by multiplying the number of completed wells with the estimated well length. The well length is determined by looking at the reservoir depth and the wellbore length. In down left corner, we have the drilling time, which is determined by looking at the number of days between spud to completion. And then on the lower right corner, we have the rig demand. And the rig demand is a measure in years, and we arrive to this number by looking at the drilling days divided by 275 days. The number 275 days is assumed to be the effective number of drilling days per rig per year, and that's why we divide by this number. So hopefully you now know what is in the well cube. So my plan now is to explain the methodology behind the data. And we visualize this by looking at the product offering again. So as I already mentioned, well cube contains development and exploration wells for all assets in UCube. It contains both onshore and offshore assets, and both conventional and unconventional assets. And this information is fed from several other cubes in the Rystad energy universe. For instance, exploration wells are derived from the E-cube, which you see under the global E&P solutions. Unconventional wells, or shale wells, are retrieved from the NAS universe, so the Nasol cube and the NAS cube. And then the offshore development wells are retrieved from rig cube. This methodology ensures that the well data is consistent across the whole Rystad energy cube universe. Onshore development wells consist of historic reported wells, and when we don't have reported wells, we use well models, which is determined by the well machine, which determines the number of wells required to realize UCube production profile. Sources for historical wells are, among other, official governmental data, company reports, reports from relevant industry organizations, and public media. The historic data is used to calibrate our models and further improve our forecasts. But as I mentioned, sometimes we don't have reported data, and then we have to use models, which comes from the well machine. So I want to explain how we arrive at, or how the methodology in well machine works. So I created 3 charts here, which I want to show you. So the first chart, we look at well demand per field, which is assessed by individual well performance. The curve below here shows a typical production profile for an individual well. And there are typical 5 parameters determining the well performance. So firstly, number 1 is the initial production. Number 2 is decline rate to the end of plateau production. Number 3 is the decline rate to the end of the well lifetime. Number 4 is the well lifetime itself. And number 5 is the initial production decline. Based on the characteristics of a specific well, we further group all historical wells into a library of well models, and based on the project characteristics such as geography, hydrocarbon type, etc., we can then apply appropriate well models to future projects to understand the total development drilling demand. So when we have chosen the right well characteristics, we can then add together the different individual well production profiles, and we can sum those single well profiles together in order to arrive at the total production of the field. So hopefully this gave you a bit of understanding of our methodology. Now I will move over to some case examples. So typically one can use the well cube to look at macro trends. These include the global well count and rig demand. You can split this by regions, countries, and even assets. You can look at the drilling length and split by the same measures, drilling times, and you can also split all this data on the operators. Secondly, you can do customer analysis. So you can identify your client and look at their drilling plans going forward. How much drilling will be done on already producing fields, how much drilling will be done on discoveries, and how much drilling will be done on exploration licenses. Third topic here is benchmarking. So you can examine the different drilling trends for different countries and look at development plans going forward on different countries. You can screen the market for opportunities, and lastly you can look at field research. So you can look at individual fields in order to see how much wildcats and development wells that will come on that specific field. Here is an example of macro analysis. So the left chart shows numbers of wells split by continent, and as you can see, we expect a huge number of wells in North America going forward, driven by the shale industry. On the right hand side, we split the rig demand for these wells on continent and countries. And as you can see, we expect a lot of rig demand in the United States, China, and Russia. The left chart here looks at the drilling days in different countries. So here you can benchmark different countries against each other. The right graph visualizes the drilling length by operator. So then you can position yourself with regards to drilling equipment based on the drilling length for different assets. Here we are looking at the operator DNO, and we can start to see how many development wells, how many wildcats, and how many appraisal wells they will be drilling on specific assets. On the right hand side we have a table with different items. You can look at the reservoir rock, the unconventional type, the temperature of the reservoir, and also the pressure of the reservoir. Lastly, you can look at the age of the different wells. So you can drill down to a specific country and look at the age of the wells in that country in order to understand how much brownfield activity these wells will require going forward. On the right hand side, we look at the specific well demand for a specific field, where you see the appraisal, drilling, the development, and the infill wells. Lastly, we do have a macro analysis on the well count. So after the oil price drop, we saw that the onshore drilling slowed down, but we expect the market to pick up again going forward, especially driven by the shale industry. But bear in mind that this is highly dependent on the different oil price scenarios. So the picture won't look similar if the oil price falls to $50 per barrel again. And the most active drillers in terms of operators are PetroChina, Sinopec, and then we have some Russian operators before American operators follows. And even though the well count increases going forward, we see that most of the activity is related to already producing fields. By that, we have summarized the well cube, and hopefully you have an understanding of well cube. So now I will show a case example of how you can do cost benchmarking in D cube. So the cost benchmarking is visualized by 4 graphs. So on the left hand side we have lifting cost, and on the right hand side we have greenfield costs. So I will first explain the lifting cost. And by lifting cost we mean investments on already producing fields normalized on the production number each year. Here you can see that we can benchmark different countries on overall level based on their investments, and the graph on the upper left corner shows that Norway has the lowest lifting cost compared to Brazil, Angola, United States, and Indonesia. The lifting cost can also be visualized by splitting on segments. Next, we have the greenfield cost, which is the development cost of of a field normalized on the reserves. This can also be split by countries and segments, but also other dimensions of the cube. For instance, the shelf and deep water supply segments. In down the right corner, you see greenfield cost benchmarking by asset. So here we can benchmark different assets against each other, see which segments that drives the greenfield cost, and compare different assets of interest. So I think that summarizes the benchmarking possibilities in DCube. I will now, on my last slide, I will show you how we do revenue forecast in SCube. So forecasting in SCube is based on future demand from oilfield services, and this number is taken from UCube and DCube. So roughly explained, UCube, the upstream database we have, consists of information, production, reserves, and economics informations on all oil and gas fields, discoveries, and exploration licenses globally. We take the economic data from UCube and feed this data into DCube, where we split the economic data into the different oilfield service segments. And since the oilfield service segments are the same in both DCube and SCube, we can then extract the future segment-wise demand on country level from DCube in order to determine the future revenue market volumes for each segment and each country into SCube. And before we distribute the market volumes to the service companies based on historical market shares, we firstly apply execution years and values for known oilfield service contract backlog within each segment and country to the awarded companies. And the difference between the expected market volumes in bullet point 1 and the value of all the known oilfield service contracts in bullet point 2 within a specific segment and country is then distributed based on the average market shares over the last 5 years for the different service companies. And then if we combine bullet point 2 and 3 for all segments and countries, this will then make up the total revenue forecast for a specific service company, and we do that for all the 450 service companies in SCube. By that, I think my presentation is over. So,
thank you for listening in, and thanks Lars for giving this fantastic overview of our OFS solutions. With this, we conclude today's webinar. You will shortly receive a follow-up email with a link to the webinar recording and sign-up details to our free monthly newsletter publications. If you would like a more in-depth product demonstration, please don't hesitate to contact us, and one of our sales team members will be in touch. Once again, thank you for attending.